Hi everyone. In this video we are going to discuss about the Heron's formula for the area of a triangle when the three sides of a triangle is provided. So suppose we have a triangle ABC, as you can see in the diagram here on the left hand side, the green triangle. We have been given the three sides of that triangle. Say suppose the BC side is of length A unit, and then AC side is of length B unit, and then AB side is of length C unit. Now if the three sides of a triangle are given, we have to find out the area of the triangle, and there is a formula which was developed by Heron of Alexandria. He is a Greek mathematician. He came up with this nice little formula that says that, if you have given me three sides of a triangle, then the area of the triangle would be square root of S times S minus A times S minus B times S minus C. And what is S? S is the half of the perimeter. So whatever is the perimeter, S is half of that, meaning A plus B plus C by 2, that is equal to S. So if S is the half of the perimeter, then the area of the triangle would be square root of S times S minus A times S minus B times S minus C. Now let's see how to derive this formula. Now I'm sure Heron did the derivation somehow, whatever way he may have done. I am not aware exactly how he did it, but I am going to do it using the Pythagoras theorem and simple algebra. I am going to derive this formula here. So let's get started. Now before we start with the derivation, I want to do one minor modification with this with the diagram that I have already done the modification. I dropped a perpendicular from the point C, the vertex C, onto the line AB. So on the AB side of this triangle, I have dropped a perpendicular CD. The perpendicular name is CD. It's a dotted yellow line, and that's a perpendicular line on the line AB. So on the line AB, I have a perpendicular line which is CD, and I have mentioned that the length of that perpendicular is H. So let's assume that the length is H. And when we drew the perpendicular, it actually the point D divided the line AB into two parts, right? One part is AD. So let's assume that AD is equal to X units. So let's assume AD is equal to X, and then DB would be C minus X, because our original side length of AB was C. So that would be C, which is the total length of AB. And then if we subtract the X, then we get the DB portion. So DB should be C minus X, right? And then CD, the perpendicular CD, let's assume that is H units, right? So CD is H, DB is C minus X, and AD is X. And with this, let's get started with the derivation. So first, we are going to do something with the first little triangle, which is the ADC triangle. So from ADC triangle, what do we get? It is a right angle triangle. Obviously, the triangle ADC is a right angle triangle, and then we can use the Pythagoras theorem. So from here, we are going to get that x squared plus h squared would be equal to b squared. So we can say x squared plus h squared is equal to b squared. And from here, we can say, okay, then h squared is equal to b squared minus x squared. And also from here, we can say h is equal to, so from here, we can say h is equal to square root of b squared minus x squared. So now we have three important pieces of information that we're going to need. So I'm going to highlight them. So this is one little equation that we have, that h squared is equal to b squared minus x squared, and also h is equal to square root of b squared minus x squared, right? We don't know what is x yet. We don't know the value of x. All we know is a, b and c, the lowercase a, b and c, which are the length of the three corresponding sides of this triangle, right? So we don't know x, we don't know h, and we are going to find them out soon. So with that, now let's scroll down a little bit and let's now focus on the next triangle, which is our triangle DBC. So from DBC triangle, what do we get? Well, from DBC triangle, we are going to get, again, we are going to use the Pythagoras theorem. So there we can say that h squared plus c minus x whole squared should be equal to the square of the hypotenuse, which is a squared. And then from here we can say, okay, so h squared is equal to a squared minus c minus x whole squared. And this is another important information that we are going to need in our process here. So let me highlight that. So now as you can see, from the triangle ADC, we got the value of h squared, which was equal to b squared minus x squared. And then from triangle DBC, we got h squared, which is equal to a squared minus c minus x whole squared. So the value of h squared must be equal. So we can say, from here we can say that h squared from the triangle ADC, which was b squared minus x squared, so that was the value of the h squared for triangle ADC, that must be equal to the value of h squared that we got from the triangle DBC, and that is nothing but a squared minus c minus x whole squared. And then we can say, okay, this is equal to, let's remove the parenthesis now, so this will be equal to a squared minus, okay, within parenthesis, let's keep the parenthesis here, so it would be c squared minus 2 times cx plus x squared. And then in the next step we are going to remove the parenthesis, so in the next step we can say, okay, this is equal to a squared minus c squared plus 2cx and minus x squared. So essentially this is b squared minus x squared is equal to that. Now from here you see we have x squared, negative x squared on both sides, that's going to cancel each other. So the negative x squared going to cancel each other. And then what we get? Well, from here we get that b squared is equal to a squared minus c squared plus 2cx. And from here we can say, okay, then if we keep the 2cx on the right hand side, so this will be b squared, and let's bring the a squared and c squared to the left hand side, so that will be b squared plus c squared and minus a squared. So we are bringing them to the left hand side, and on the right hand side we are keeping 2cx. And then from here we can say 2cx is equal to b squared plus c squared minus a squared. And from here we can say, okay, then x is equal to b squared plus c squared minus a squared whole divided by 2 times c. Now using this value of x, we are now going to calculate the value of h. So the value of h would be square root of b squared minus x squared. So the value of h would be square root of b squared minus x squared. So we can say that h would be equal to square root of b squared minus x squared. That is the value of h. And then we can say, okay, this is equal to square root of, let's say we have b squared, so we are going to keep the b squared as is, and then minus, we are going to now replace the value of x that we got. You see, x is actually equal to b squared plus c squared minus a squared by 2c. So we are going to use that value of x. So we have x squared here, so I am going to use the parenthesis. Then we are going to say b squared plus c squared minus a squared whole divided by 2c and the square of that number. So that is our h. So h now so far is looking like square root of b squared minus this other whole square, right? So from here, let's do the simplification a little bit. So we can say that this is equal to square root of b squared minus, let's keep it here. So we have b squared plus c squared minus a squared. We are keeping the whole square there, and divided by, when we square the 2c, so 2c become 4c squared when we square it. So this is our value of h so far. And then if we do the subtraction here within the square root, so inside the square root we are going to do a little subtraction, and there our denominator will be the LCM, which is 4c squared, and then in the numerator we are going to get 4c squared times b squared. So that would be 4b squared times c squared. 4c squared times b squared can be written as 4b squared c squared, and then we are going to get minus b squared plus c squared minus a squared and whole square of that. So that is the value of h so far, right? Now we know that the area of a triangle is actually half base times height. So in our triangle, let's see what is the base and height. So our base is actually the line AB, the side AB, whose length is c units. So that's the base and the height is h. So the area of this triangle would be half into c into h. That means half base into height, that would be half c into h. So now we are going to calculate the area of this triangle, right? So the area of this triangle now would be equal to half times base is actually c units and times h, because we have already calculated the value of h. So here if we use that value of h that we have gotten so far, so we can say, okay, the area of the triangle now going to be like this. So we can say, okay, this is equal to c by 2 times square root of, so let's use the value of h, that is 4b squared c squared, 4b squared then c squared, minus we have b squared plus c squared minus a squared whole squared, and then we have that whole divided by 4c squared. So that is the value of h that we just substituted. And then if we bring the c by 2 inside the square root, it will go inside as a square, so it will go inside as c squared by 4. So inside the square root, now we are going to bring the c by 2 inside the square root. So c by 2 comes here as c squared by 4 times whatever we have. So c squared by 4 times whatever we had, and what we had there, well, we had 4b squared c squared minus we had b squared plus c squared minus a squared whole squared and divided by 4c squared. And you see that this c squared right here and this c squared right here, they're going to cancel each other because one of them is in the numerator, the other one is in the denominator. So then from here what are we going to get? Well, from here we are going to get something like this. So from here we get the denominator will become 4 times 4, that is 16. So in the denominator we are going to get 16. So let me write that down. Denominator will be 16, and all of this is under the square root, the entire thing is under the square root. So then we have 4 times b squared c squared. Can we write it as 2 times bc whole square? So we are going to write the 4 times b squared c squared as 2 times bc whole squared, and then minus we have b squared plus c squared minus a squared and whole square of that. So that's the value of the area so far, right? Now let's do a little more algebra to come to the final step. So now from here we can say, okay, so this must be equal to square root of, we're still going to keep the 16 in the denominator. So we have 16 in the denominator, but in the numerator, let's see. Now you see there is a nice form there. It's like a difference of 2 squares. It's like a squared minus b squared, or you can say x squared minus y squared, right? So it's a difference of 2 squares. So we should be able to factor them easily. So let's factor it, right? So when you do the factorization, it is going to look like this. So it would be 2 times bc plus b squared plus c squared minus a squared, that would be one factor, and then the other factor would be 2 times bc minus b squared minus c squared plus a squared, right? Those are the two factors we get, and then denominator has 16. So from here, let's try to simplify again. So from here, we're going to get something like this. So here, as you can see, it is b squared plus c squared plus 2bc, that is b plus c whole squared. So we can say, okay, in the first factor, we have b plus c whole squared and then minus a squared. That is our first factor. And then in the second factor, what do we have? Well, in the second factor, if you carefully see, we have a squared minus, can we say it like this? Minus, we can say, okay, this is b squared plus c squared minus 2bc. That is our second factor there. And then we have all of this whole divided by 16. And the entire thing is under the square root. So from here, what do we get? Well, from here, let's see. So from here we can say, okay, this thing looks like the first factor is b plus c whole squared, and then minus a squared. That's the first factor. And the second factor now looks like a squared minus, we have b minus c whole squared. That would be b minus c whole squared, right? And then denominator has 16. And then within each bracket, we see that we have again difference of two squares within each bracket. So that's going to be pretty interesting. So let's factorize again. So within each bracket, we are now going to do the factorization. So the first bracket, we get b plus c plus a times b plus c minus a. And then from the second bracket, we are going to get a plus b minus c, and then we are going to get a minus b plus c. Those will be the two factors from the second bracket. And now in the denominator we have 16. Now what I am going to do, I am going to distribute that 16 in this form. So we are going to give a 2 for each of these factors. So we say, okay, here is a 2, you get a 2, and this factor also gets a 2, and this one also gets a 2, and this one also gets a 2. Everything okay so far? Now from here, you see, now we are going to reorganize slightly. So from here, we can say, okay, this is equal to, the first one is, can we write it as a plus b plus c divided by 2, and then times the second one, can we write it as a plus b plus c, a plus b plus c, and we have to finally get a negative a, so we can say negative 2a. That makes it b plus c minus a. If you think about it, this is nothing but b plus c minus a, and then we have a 2 there on the denominator. Then for the third one, there we can say, okay, can we write it as a plus b plus c minus 2c. There also we have a 2 in the denominator. And then for the fourth factor also, can we write him like this? Can we say, okay, this is again, I can say a plus b plus c minus 2b, and then divided by 2. So now things are taking a nice little shape here, right? So now from here we can say, okay, can we write it like this? So this is now going to look like, this. So we can say, okay, this is a plus b plus c divided by 2, and then times, here we can say, okay, we are going to distribute that. So this will become, so let's use a parenthesis here. So this will become a plus b plus c by 2, and then minus 2a by 2. That is one of those factors. Then the next one again going to look similar. We're going to do similar thing for the next one. So for the next one, what are you going to do? We are going to say, okay, this is also a plus b plus c divided by 2, and then minus 2c divided by 2. And then the last factor also going to look similar. It will be a plus b plus c divided by 2, and then minus 2b by 2. All right, so we are almost done. Now from here we can say, okay, so this is going to now look like, square root of a plus b plus c by 2 times a plus b plus c divided by 2, and then minus a, because the 2 and 2, they will cancel each other. So this 2 and this 2 will cancel each other. And similarly here also, this 2 and this 2, they will cancel each other, and this one and this one, they're going to cancel each other. So from here we get, this is nothing but just a, and then times the next factor is like this. We can say a plus b plus c by 2 minus c, and the last one is a plus b plus c by 2 minus b. All right, so we are almost done. Now you see, what is a plus b plus c by 2? Well, a plus b plus c by 2 is nothing but the half of the perimeter, which is actually right here. As you can see on the right hand side here, the given condition is that S is actually a plus b plus c by 2. That means half of the perimeter. So wherever we have a plus b plus c by 2, I am going to replace that with an S. So let's do that. So here we can say, okay, this is equal to square root of The first a plus b plus c by 2 by a plus b plus c by 2, we can say that is s, and then times here again s minus a, then times s minus c, and times s minus b. And if we just rewrite this expression here, we can say, okay, this is nothing but square root of s times s minus a, and then I'm going to write the s minus b factor. So we say s minus b, and then I'm going to write the s minus c factor. So this is the formula that we wanted to derive, right? And this is nothing but the area of the triangle. I hope the derivation steps made sense so far. Thank you for watching. See you in the next video.